Okay, so we discuss list, sets, now we should discuss maps. And maps are really powerful. Maps are one of the best concepts in Apex and in general programming languages. The more you program, the more experience you get, the more you fall in love with maps. And I'm a big fan of them, and they allow you to do very cool things in a very easy way. But not only they're cool, they're also required for you to understand such topics like triggers, for example. And it's really hard to imagine Salesforce development without maps. I would say it's even impossible. So just a reminder that set is a list without duplicates and order, right? So basically, let's say we have here a set of names or whatever we call this set, and we add there A, B, C, and you can see that we are adding here B, A, and then C. And how they're displayed here in the debug, A, B, and C. So here first we added B, but A is displayed as the first one. This is an indicator that we actually don't have an order in our sets. And this is important to keep in mind. There's no such thing as the first element in a set. You cannot say it. So if you want to iterate through a set, you have to iterate through the whole set. Or maybe through a part, but you have to iterate through it. You cannot just get the first element out of set. And the reason why we discuss it is because set and lists, they are underlying concepts for understanding maps. So from all the three collections that we have, only lists are ordered. Sets and maps are unordered data types. So what is a map? Map is basically just a table with two columns. It's very, very simple. You can imagine it like this. We have a key and we have a value. And we can add to this table some values. Or better to say, we can add here some pairs. Because we never can add only a key and only a value. We always can add a whole row. And we do it with a put. We will go into detail and I'm going to show you how to do it in a second. But basically, when we put it, we add here one value and then another one. It is different from comparison to the list, for example. In the list, we had always only one value, right? So you had names.add and then you put the value there. No, here it's always a pair. And like this, you can add a little bit more stuff. We can also get some values from the map. And to get values, we use the same get method as we used for lists, for example. But now the thing is with the get method that we cannot really get a method based on the index. And it makes sense because remember what I was talking, that maps are unordered. So we can't really we don't have an order, so we don't have an element number 0. Even though I know in this table it looks like we have the first, the second element, they are not ordered. And even more, the order of the elements is not guaranteed in the map. So you cannot even rely when you write Apex, you can't even rely that they're going to be in the same order. And in most cases, I think maps are sorted by the alphabetical order by the Apex engine, but again, you cannot rely on those things. And here's an example how we can immediately declare a map variable and how we can immediately initialize this map. Value in a map can be any type, but about a key, we need to make sure that the key is unique. Let's imagine what would happen if key was not unique. So let's say we have here two keys, Alex and Alex. They point into different values, Smith and Klein. When we say map.getAlex, give me the value behind Alex, what would you expect to receive? It's not clear, right? So Apex Engine can't really know what to give you at this point. So that's why we make the keys unique. And because we make them unique, there are certain data types that don't really work well as a key in map. For example, as object, for the same as we discussed for sets. If you're not sure, we discussed this topic in the set video. You can go back. I explained that as objects are not really good, or booleans or decimals are not really good as unique values. So we cannot really use them first row. And again, the same as for sets, we usually use string ID or integer as a key. And in most cases, that would be an ID. So before we go into this thing, let me show you how to create a map. So map, first we actually write the keyword map, right? So it's going to be map. And here we have string and string. With list, we had only one data type, right? Because we were specifying here the type of elements we have. Now with the map, we need to specify two types because we have two columns, right? Remember, it's a table with two columns. And let's call it names equal new map string and string. A lot of people do something similar, something like name map names map. It's not really correct to do that, because you're, again, in terms from the best practices, of course you can do it. You can name your variables as you want. You can even say here n, and it's going to be fine from the Apex perspective. But from the best practice perspective, you try not to duplicate the information that you already have here at this point. So map is already defined here. You can see that it's a map. You can clearly see it because you always create a variable, and on the left part of the variable you always see the type. So map is already there. You don't need to overload your variable name with additional information. Names, and let's add to the names. Add Alex, and now here Alexander. And then names.add John Johnson. And then names.add what else should we equal? Something like this. And now let's put it out. System.debug names. Execute. You can see that we don't have the add method, and that was my mistake because we don't have add method anymore. The idea is the same. We are adding some information to the map, but now it's called put. Let's see. Yeah, we can see here different values. Now the thing here is that you can see how they're displayed. So they are displayed literally as pair. This is always a pair, right? So they have here equal sign. This is element number 1, element number 2, and element number 3, but we don't have this numeration. I say just 1, 2, 3 because we see it in this order, but the order can be anything. And again, we don't really have this 1, 2, 3 thing with maps. So that's why you can also go and have this type of syntax where you can write it like this, and you can say that Alex will be pointing into the Alexander, right? And then we can delete this one, and it's going to be the same. Just here you add this this greater than sign. Otherwise, it stays pretty much the same. Let me execute this. Yeah, you can see it's the same. And again, I think the order here doesn't really matter because you see that we are adding Igor, my name, we're adding it as a third value, but it is displayed as a second value. There's not even such thing as a first or third value. What do you think? What happens if here, instead of John, I'm gonna put test? You see, we have two different values for the same key, John and John. What do you think we're gonna be seeing at the end? Or maybe we're gonna have an error. Just give a guess and let's see. No error. And you can see that John is equal to test. So what happened is that this line, it overrode the value that was behind this. This is why we call it put, because you literally put some value, some pair into the map, but when you put it, you don't really look if there's already key behind it. You just put it. If there's a key behind the key that you're trying to put, you will just overwrite it. If there is no key, then you're just going to create a new entry. Another question, we can get the values, right? So for example, if I get here John, we're going to be able to see the last value. So we're going to see test here, right? What happens if I'm going to say something like this? So if I'm going to say get, and I'm going to pass here a key that does not exist. An error? No. We're going to see null. And what it means is that behind this key, there is no value behind this key. There are some important methods that we need to consider with maps. Some of them we already discussed, so put and get we already discussed. There's also key set values, remove and contains key. They are kind of important, so let's discuss them a little bit more details. You can get first column of the map or the second column of the map by using key set. Why is it important? Because sometimes you have a map and you don't need the whole map. You want to have only the key set. For example, you have a map with IDs that are pointing into the account records. So the first row is all the IDs and the second is all the accounts. What if you just want to quick get the IDs of those accounts? Instead of iterating through whole map and getting the IDs, you can just say map.keyset and you get the first row in the table. So the first column in the table. And you can do the same with values. So you can get the second value. Now let's have a look, how does it look in Apex? So we have here our map, right? Let's say this map is string to integer. And let's call it people. So now we have here, and I'm also going to remove this one. I also don't really encourage you writing this type of syntax, where you write immediately everything on the initialization. You can do it, don't have to do it. I personally just prefer writing it that way. So here we have people with a different, so let's call this one Alex, right? So we have people here in different ages. We want to show the whole key set. So what I'm going to do, okay, so we still need to substitute here people, and then key set. It's a method, right? So key set, we see here parentheses, so it means that it's a method. Let's execute it. Okay, you can see Alex, Igor, and John. And the same we can get values. Execute. And you can see here the values. So the values itself, they're usually not that useful. Okay, what if I want to save the key set? Let's focus on the key set. What if I want to save the key set into a variable and then use it somehow? For example, I want to iterate through it. I want to show all the possible keys here. Surprisingly enough, it's a set. And this is something very important to understand and really internalize in your head, that the first column of a map, it's represented with a set. So when you get a key set, when you get all the keys of this column, it's actually a set. So string, let's call it keys, for example, equal to people.keyset. And now you already know how to iterate through a collection, and set is just simply a collection. So we can just say system.debug and key plus key, like this. Let's execute. Does not exist. Key, why is it not existing? Because here we need to iterate through the collection. Okay, so key is John, Igor, and Alex. And this way you can already see how we can do the same with the values. But now here's an interesting thing. Let's just change it to the values. Let's execute it. And you see illegal assignment from list integer to set string. Well, that makes sense, because the right part, first, it's an integer, not a string. We're trying to assign it to the set of strings, so we cannot do it. But second, you also see that this is not only integer, that's also a list instead of set. Well, why so? Well, because in our map, John 20, Igor to 30, we can also have duplicates on the right part. So we don't have, yes, keys, they have to be unique, but the values, they don't have to be unique, because why would we need unique keys, right? We enforce the uniqueness of the keys because we do need to have unique keys, but we don't need to have unique values. We enforce the uniqueness of the keys because we want to make sure that we don't run into the problem where we don't know how to get a certain value, right? So if we had here John and John, and that would be 30, if we say, give me the value that is behind John and John, like which one should we get? And we discussed it in the last video. So here in this one, John, Igor, we can have repetition here. right? So if you want to iterate through the values, you have to iterate through the list. And values are represented as lists in Apex. Integer key, and here I would say value from values. Key does not exist, yep, because I forgot here this key variable. It's executed. 20, 20, and 40, right? So we don't have to do it. Basically, you can imagine it like this. We can separate a map into two different columns. And we can say map.getKey, and we get the key. We can get here key set, which we're gonna give us the first column, and value is gonna give values, and then we can put key and the value. Another example that we have is contains key. If you want to check if the map contains the key, so for example, red and blue, and those are hexa representations of those colors. If we say contains key blue, we're gonna see it through here because it does contains blue. We also have remove, so we can remove some values. If we remove here based on the blue, we're gonna remove the whole row. We cannot remove just one key. We always deal here with pairs, so we remove either the whole pair or nothing. Now, how do you iterate through a map? Well, there's one way that you already probably can guess. So if we look here, we have the keys. If you know the key, you can already get the value. So here you know the key, right? And then you can say integer value would be equal to people.get key. Remember that there is no native way to iterate through a whole map. We have to work with this type of iteration. So if we use the key here, we can go and say this is the key plus here's the value, and let's output the value. Key would be equal, let's see if that's correct. Key John, value 20. Key Igor, value 30. Key Alex, value 40. Seems to be right. So you get here the keys, and when you know a key, you can get the value. So you get all the keys that you need, all the keys from the map, and this is a set, and then you iterate through every key and you get the value of this key. And then you can use this value as you want. If you want to iterate just through the values, so if you want to say here values list, and then it would be an integer, you wouldn't be able to display this key here, but you still would be able to write something like value equal to blah, 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 right? So let's write it here, values, and here it's an integer, and then you don't need this part. And then here you say values. So here you get the values from the map, you save it into the list, and then you iterate through this list and you display those values. But of course it has a problem because now we cannot really have the keys, so we don't know the keys. So if you have some kind of functionality that involves the whole pair in your map or iterating through the whole pair, then you won't be able to use this approach, which usually you have. So usually you want to iterate through the whole map immediately, not just values. And by the way, you can also write here something like this. So you don't have to create a new variable. You can just use this one, and that's going to be the same outcome. So here how we can visualize those things. If we only want to iterate through the values, like here, for example, we use this value, that approach that I showed you. I just wanted to show you because that's something that you might want to do, but it's very rare that you would need it. Usually you iterate through a whole pair, and then you start with the keys by getting the keys, and actually you're not iterating through a map. So yes, at the end you end up iterating through a map, but physically what you're iterating through is actually a set of keys that you get from the map, not the map directly. Here would be the step number 1, that would be the step number 2. So on the right you see the right way of doing that. From Alex to Smith, so we iterate through a whole pair. Here we iterate through a whole pair again. And that's, in most cases, what we want. Here's another example how it looks in the real world. So, for example, we have here John Miller, and then we iterate through the whole key set. Okay, we also have quite a difficult topic that we need to discuss here. It's not really a topic, it's just a way of writing maps. You can solve certain tasks. And at first, when I first learned how to do it, I was really frustrated by this thing. Like, I was really frustrated, I tell you. I could not understand it, and it took me a while to understand this whole process. So if it takes a while for you, that's also fine. So what do we want to do? We want to write a method called countWords. It accepts a list of strings, and it returns string and integer map. And it counts how many times a word is presented in this list. So here's an example. Here's how it looks like, right? So we have public static. You can do it static. You don't have to do it static. Map, string, integer, count words. You can also use the developer console for that, doesn't really matter. And then you need to return the map itself. Here's an example. So let's say we get a list of strings. Alex, John, Oliver, Alex, John, Alex again. Alex is 3 times in this list. John is 2 times in this list, and Oliver is 1 time in the list. Alex is that many times, John is that many times, Oliver that. So this is basically a map, right? You see 2 columns with the key and values, and this is what we want to get. And this is useful, for example, to give an example from real world. It's useful when you can, for example, you are asked, okay, can you count how many accounts in each industry do we have, and then perform some logic based on these groups. For example, update opportunity close dates on all the industries that have more than 50 opportunities in them. For this example, you can create a map where you're gonna map banking has that many opportunities, education has that many opportunities. So this is going to be basically the same algorithm that you would need as for this task. So this on the left side, we see our map. And on the right side, you see our decision. First, I'm going to just walk you visually of what's going on there, and then I'm going to go and actually code this task. So you see here that we have a name, and name is equal to Alex. And we ask ourselves, is the name in the map? Well, no, of course, the map, look at the map. The map is empty. No, it's not in the map, so it's not in the map. So if it's not in the map, then put key with value 1 in the map. Okay, let's go to the next, to the John. Is John in the map? No, not in the map. Again, we just do the same all the time. Whenever something is not in the map, we just put it with the value 1. Oliver in the map? No, 1. Now, Alex. Alex was already in the map. In the map? Yeah. When the key is already in the map, you just need to update the key, the value behind this key by 1. So if it was 1, it's going to be 2. No. And this algorithm, if we just repeat this algorithm, and you can feel already this like loop cycling algorithm with this decision tree, is that if we repeat it for all the elements here, we're going to end up having what we want. So now John, is it in the map? Yeah, in the map. So let's add John to the map. Alex in the map? Yeah, let's update. Now let me show you how to actually code this thing. I'm going to create here a new class. Let's say maps examples. And here I'm going to create public map string integer count words, and we're going to accept here string words. The first thing that I do is I usually instantiate the map immediately. So let's say it's map to return new map, and then return map to return. Usually you don't call them like this, map to return. Let's actually change it, and let's call it, usually you call it in the way that it indicates what's actually going on with the map. So something like, for example, word to count, something in this regard, word to count. Now we're gonna need to iterate through the list, right? Because we want to consider every single element in this list. We want to count how many times it's already there. So we have to iterate through it. Of course, we're going to be using for each loop. So from words, word to count. Now we need to have the if, right? So remember this type of transition where we were considering, is it in the map? Is it not in the map? The same here, we need to have a look. So if, and let's say it in in the map, then do one thing, otherwise do another thing, right? Else do something else. So first, if it's not in the map, let's just first try to get what happens if it's not in the map. If it's not in the map, then we need to put here word to count dot put. We put the word itself and 1 because we want to instantiate, basically start the whole counting process, right? So here in the first one, when it was not in the map, we added Alex with 1 when we were iterating through the first element. The same goes here. So we add here with 1 element. And if it's in the map, then we do following thing. We get what is the value behind. Value behind would be word to count dot get word. And then we overwrite the value that is behind. So we say put word, and then we write there value plus 1. And now only this in the map check left. And to check if it's in the map or not, it's very easy because we have a special method for it. Word count dot contains key, and then we pass there the word, and that's it. Okay, let's now create and call this method. So let's say we have here maps examples, new map examples, and system.debug examples dot count words, and then we are passing their names. Those are exactly the names from the example that I have. So names, execute, and you can see Alex 3, John 1, and Oliver 2. Now what if we change it? What if we add here more Alex, and then we add here Iger, and then we add here Alex again. Execute. Still gonna work, so it counts correctly. Congrats! If you can understand this whole process, you will be good with maps, because this algorithm is quite frequent thing what we are using. Thank you. Now go practice. I want to discuss the topic of PICO notation because very few people actually discuss this topic, and quite understandably, because this is a topic more kind of computer science stuff. But having an intuition behind those things is still important for any developer, especially if you're self-taught. You don't have to go all the way up to the math behind all of this stuff, but you have to understand the basics and have an intuition behind it. So here's an example. We want to calculate the sum from 1 till n. So let's say from 1 till 100 or 1 to 1000. I want to calculate the sum. There are two solutions possible. You see on the left side, you see one solution with the for loop. That's usually the way people would approach it. You would create here an integer sum equal to 0, and then start with iterating with 1 and go up to n and I++, and then sum is equal plus to equal I. And this way you aggregate all the sum. Well, this is one approach, and the second approach is here. And the second approach is the one on the right side. A very smart person actually decided to calculate that. It's actually possible to calculate the sum with just using this formula. You multiply n with n plus 1 and divide by 2. So if we have 100, we multiply 100 with 101 and divide by 2. Quite smart, so you don't need any loop to do it. What is your intuition behind? Which solution is better? Which solution is more performant? Most people would say on the right part, on the right side. And that's true, because you feel that the solution on the right part doesn't take that much of computation as the one on the left. That's the right intuition behind it. But how can you quantify what is the good or performant in this case? You can think about input and output. So let's say we're gonna put different values into our computation. So let's say here n is equal to 10. We're gonna have 10 iterations, right? So we're gonna go from 1 till 10, 10 iterations. 100, 100 operations. Or iterations. Iterations, operations, the same in this case. 1000, 1000. 10,000, 10,000 operations, right? So you can see that it is we do exactly the same amount of operations or iterations as n grows. So this is so-called linear, right? So you increase your input and this with the same rate, the amount of operations you perform grows. This is very typical for most of the operations that we have in Apex. But the one on the right part, it doesn't scale that big. It is all the time just one operation. Doesn't matter how much is your input, you're always going to perform only one operation. And this is what's so incredible about the solution. Which means that you have a constant time. Doesn't matter how big is your input, you're always going to perform exactly one operation, which is just insane to think about. Because think that, let's say, to process a list of 1,000 inputs, 1,000 accounts, let's say you want to change a name of 1,000 accounts. You will need 1,000 operations. But what if you had a special algorithm where you put a list of 1,000 accounts and you only perform one operation to change all of them? And if you put 1,000,000 accounts, you also use only one operation, and it costs the same time as to process 1,000. What if you put 100 million accounts and it costs you the same as processing just 100 accounts? Well, that's quite cool thing, right? And this is exactly what's happening with this formula, just we don't have this operation for the accounts, which we have it for integers. But the underlying principle is the same, that no matter what is our input, our amount of operations won't change. And if we put it in the fancy words, basically it means that on the left side we scale linear, and on the right side we have a constant time complexity. It's usually called time complexity. And we have different types of complexity. The biggest one that we of course want to go for is O from 1 or linear 1. Linear is also really good. What we want to avoid is probably this type of curve. You see, for example, this one exponential, somewhere here exponential is not really shown here. We have quadratic one. So it means that if you input 100 operations, you get like 1,000 as an output. Here's an example. N is equal to 10. How many iterations do we have? 100. Because we go here from 0 to n, and then again from 0 to n. So all the time when we have 100, we're going to perform this system.debug will be outputted 100 times. Now, when we scale it, so let's say we increase our input by just 10, right? So 10, now 10 more, we multiply our input by 10. But the amount of operations doesn't multiply by 10, it multiplies by 100. So you see that the jump between those two numbers is so much higher than between those two numbers. And this is exactly what is bad about this complexity, is that each step, even the smallest step, will result in really huge exponential growth of your complexity, how much time it takes to process your input. So for example, here for 1,000, we're going to have this huge number, and for 10,000, it's going to be just insane number for operation. So you see, it doesn't really matter for your Apex code if you write in the beginning, if you only have like 100 iterations. All of them approximately look pretty much doable on this in the beginning. It's only once you get in this part, the linear and logarithmic, complexities, they're still fine. But this one, those complexities, they are already in the endless. So you can see if they grow so quick, you can imagine what happens even here a little bit, right? You can't even see them here on the graph, which means that basically our execution will not terminate. Now, does it mean that nested loops are bad? No, it doesn't. Because sometimes we cannot avoid this type of operations. There are some algorithms in the real world, in the mathematics or in the computer science, that you just have this type of algorithm. You cannot avoid them. But what we should strive for in Apex is that we kind of avoid them if we can, but we also need to take in real world into consideration. So for example, if you have a list of opportunities and you want to iterate through opportunity line items, that would be a nested loop, right? You have a list of opportunities and then you go through each of the children of those opportunity line items. Well, most likely you will not have a problem where you go from 100 line items to 10,000 line items, or from 10,000 opportunities to 1,000,000 opportunities. If you have that, then it's a totally different discussion, but most likely you won't have this problem, which means you don't have to think about those things, right? So you will not run into this huge exponential growth of the problem. So you will end up having, maybe you'll process 100 opportunities if you're unlucky, if you're like exporting something or importing something. But most likely you don't have to care about those things. But it's still kind of useful to keep in mind when you develop. And again, I want to emphasize it so much. Don't be afraid of nested loops, because I see so many people getting like, oh, nested loops so bad. No, they're not bad per se. Just need to pay attention to those things. You just need to keep in mind that with the nested loops, you might introduce this quadrat complexity. So you might run into some issues, but most likely you won't, because the processes in Salesforce and in Apex, they are so bound to the business processes. And business processes, guess what? They're usually linear. Business processes, they don't have super complex algorithmic complexity behind them. Where you have to pay attention, if you have a for loop, a for loop, a for loop, a for loop, and like this. So if you have 4 nested loops, that's where you need to pay attention, because 4 nested loops, it means it's n times 4. So it means that if you have 10, you're going to have already thousands of operations. That's something where you have to pay attention. But again, this is something that you have to decide case by case. Don't just judge, oh, nested loops bad or not nested loops good. We also care about readability of the code. We also care about the business logic itself. We care about all the other things. Just keep it in mind. And this thing is not only about algorithms, it's also about data structures. Here we have space complexity and time complexity. Basically, you can take the same type of logic and apply it based on the space. So how long does it take for you to perform a certain operation? So it takes linear time to put something on an array. And most of this we don't really have out of the box in Apex, right? So we have to program. If you want to program a tree, you have probably to program it yourself. So we're not going to go into this into that many details right now. So if you want to add something to array, you're most likely going to have a linear case. And this is my explanation. It's very much approximate. It's not 100%, but this is approximately my explanation why sets and maps are good. So imagine if you have some kind of unstructured data. As soon as to the unstructured data, you have to add something. It's very easy because you just basically throw it there. As soon as you have to add something in the middle of a list, for example, you as a programming language, you're going to need to go and iterate and find where you actually need to insert it here. So for example, here, add in the middle, the complexity is linear. So you need to go through all the records. So for example, you have a list of 50 elements and you want to add an element in the middle. You would need to go through 25 elements, shift them, put your element there, and then append the remaining lists. So it means that you're still going to need to process at least half of the list. And the same goes for deleting, removing, and containing. So in most cases, sets and maps, they are more performant in the space complexity than lists. This is not true. This is just like intuition behind it. So this is, don't take this table as, don't post it on LinkedIn and say, hey, Igor said that list is all from one. No, it's so much more complex than that. But this is the intuition that you should have in mind, that lists are usually less performant than sets because they are ordered. So as soon as you have this ordering part, you introduce more complexity. Maps, they are based on the sets, right? So key set is based on the map. They're usually more performant than lists. And this is why people say that maps are usually really good for performance. And that's true. So if you use everywhere maps and everywhere lists, yeah, probably maps are gonna win in the performance. But again, we have so many other stuff in consideration, like for example, readability of the code, actual functionality, how quick you can write the code, and all of that, so that it's not that important. And usually Apex is not that much about squeezing out a few seconds of a performance. Usually it's not about it. And usually the bottleneck is not what kind of data type you're using, map or list, unless you're working on something really, really sophisticated and performant. But I have, in my 5 years of experience, I haven't met a single project that was this tiny improvements in speed were super important.